Welcome everyone. It's great to see you all. Thank you for joining us for lunch today. There's going to be a few people shuffling in here as we hit noon. So as we're waiting for some other people to kind of get settled into the call, we're actually interested in hearing which topics you might want to explore at future Lunch and Learn. So please add anything you're curious about or want to dive deeper into the chat. And as you do that, I will kind of kick things off here. So I'm just going to put a little prompt in the chat for folks who are joining. So for those of you who haven't had the opportunity to meet in person, I'm Lydia Salas. I'm a project coordinator with the Wisconsin Coastal Management Program. And on behalf of the Calm leadership team, I'm happy to be able to host today's event. This winter Lunch and Learn series is all about coastline change, and today we're joined by Dave Mickelson, who's going to be diving into the Shoreline inventory and Oblique viewer and how it can be used to identify visual signs of different bluff conditions and coastline change over time. So I'm sure a lot of you have interacted with Dave in some way, seen some of his presentations, but for maybe some of you who haven't yet, Dave is an emeritus professor of geoscience, geological engineering, and water resources management at UW-Madison. There he taught glacial geology, geomorphology, and coastal geomorphology, as well as some other classes from 1971 to 2005. And in addition to his coastal work on the Great Lakes, he's done some substantial research on modern glaciers and glacial deposits. And in the last decade, his main area of interest has been shoreline erosion. So before I pass it off to Dave and we get started, I just want to do a little housekeeping. This meeting will be recorded and posted online, and I'll be sure to share an announcement when that recording is available. And then to ensure the best audio for everyone, please stay muted while Dave is presenting. And there'll be an opportunity to come off mute at the end of the Lunch and Learn to ask questions. And also, as we're going through the presentation today, feel free to put your questions in the chat, and I'll be sure to call those out when we have time. So with that, Dave, the floor is yours.
All right. Thank you, Lydia. Is that coming through all right?
Yes, it is.
Okay, excellent. Yeah, so you see this is co-authored by Jeff Stone and Jason Hochschild. They are both with state floodplain managers, and they have really been instrumental in handling the funding from Coastal Management Program and doing a lot of logistical things and getting the images onto the web. And if you want to see the images, this Wisconsin Shoreline Inventory and Oblique Photo Viewer will get you there. So you can just Google that and it'll take you to the site. And there are lots of participants involved here. There's some funding from floodplain managers and Sea Grant, Coastal Management. There's a main group funding it. But most importantly, I think the Civil Air Patrol has been responsible for doing the photos for the last several years. I did the photos in 2008, and I think in 2010, and then one or two more times. And then since then, the Wisconsin wing of the Civil Air Patrol has been responsible for doing that. And my role has just been to kind of, I don't know, be the liaison and work with them to get the best quality photos. And as you can see in the bottom right, cartographer's office, state cartographer's office, and the CART lab have been instrumental as well. I just point out that Howard Bergen wrote a paper on the shoreline inventory and its history, how it developed. And so there's a link you can see there. And if you want to look at detail, you can do that. I'm not going to spend time on the history. I want to spend more time on what it's all about. So if you go to that website, what you will be able to do is click on what photos you want to see. In this case, this brings up the 2019 oblique photos along the Lake Superior shoreline. And you can see the photo numbers are on there, and they're pins that show the location of the plane, not of the subject. And that's what's a little tricky in trying to use this, is that you don't know which way the camera was pointing. Was it really pointing 90 degrees to the shore, or was it pointing a little bit toward the back or toward the front? The attempt is to have continuous coverage, not have gaps. So at times the camera has to be moved and adjusted to make sure that there's no gaps, and also that there's not too much overlap. So that's just an example of what you can see. The map that you get on the viewer will look like this, and the oblique photos online start in 1976 and run up through 2023, and presumably there will be photos taken this May in 2024. And then Coastal Management funded me to work on a project in, or projects in the photos from early photos. You can see the range of photos there, to map bluff condition, bluff protection, and shore structures. And those are all on there as well as some other things that I'm going to point out as well. So this is an example when you zoom in, and your options here are to open one of the layers or more of the layers that you see. Here you just see an example of the, it's on Roman Point on Lake Superior. And here you can see an example of the 2023 photos, and the ones down here are the 1976 to 1978 photos. And they're done in clusters where the photos are close together. So you can see these bigger circles here have numbers in. That's the number of individual photos in that cluster. So you can zoom in, or you can just click on that cluster and then look at the 4 photos, for instance, that are in that cluster. So there's a number of ways of looking at this. If you keep zooming in, then the clusters will get smaller and smaller, and then you'll see marks for individual photos, and the clusters themselves won't show up on the map. And then the other thing that you see on here is shoreline condition. This was pretty subjective. Basically, it was categories showing that that it was erosive and there was slope failure taking place on the bluff. Mainly stable would be in green, and then there's some yellow ones that are marginal. And so those are the characteristics that were mapped, those 3 different intervals to show what when we did that mapping. You can pull up just a map that shows the shore structures at different times. So this is 2018, 2019. Use 2 different dates sometimes, because sometimes the Lake Superior photos are taken in a different year than in Lake Michigan. And all the photos, as far as I know, were done in the early summer, late spring. So late April, May, a couple of them go into June. And then in contrast, the USGS Corps of Engineers set of photos, those were done, I believe, in late July. So they're a little different in what they show. This is just an example of one of the shoreline inventory maps that was done, in this case, again, from 2018, 2019, and showing those 3 categories for bluff stability: unstable, moderately unstable, or moderately stable. This is just another example. These are shore structures and combined with bluff condition. So you have different layers and you can combine those different layers in different ways, however you like. This shows particularly structures, beach protection structures, for instance, groins, and in some cases, and seawalls, and so on. And as I say, those were mapped at 3 different intervals since the 1970s. So I know all of you are familiar with this, but just to remind you that the water level in both Michigan and Lake Superior was low for a period of time up through about 2013 or in that vicinity. And then levels went up and they got above average and they remain slightly above average. But we have a decade with high water levels after lake levels after a couple of decades of lower than average lake level. So we'll see some impact of that. For instance, here, this is the 2008 mapping of the stability of the shoreline on Lake Superior. And you can see, just have a look at that and get an impression for how much red is there, how much unstable and failing. So this is after a period of low water, and there's not as much as you'll see in the next slide, 2019, when we've had about 5 years of high lake level, and you could see substantially more red showing up. So that just indicates the change in the nature of the bluff in that time. And that shows up as well when you just look at the numbers, the amount of unstable failing bluff between 2000 and 2019 jumps from 29 miles to about 65 miles. So a substantial increase in unstable and failing bluff. And just some more information that's out there. This one I don't think it may not be on the website, but certainly there was a report done for Coastal Management Program that has that, and I can give it to you if it's something you want. Another thing that's on this site is the profiles that were done, and these are bluff profiles that were done from the 2012 Corps of Engineers LIDAR, and these were done in southeast Wisconsin, so basically from the state line north to Manitowoc County, maybe up into Kewaunee County a little bit. But those are individual profiles, and then you can see on the right in this diagram that the profile is there too. And so you can click on those and get a feeling for how high the bluff is and how steep it is at that time, 2012. So now just let's look at a few of these shoreline photographs. And again, they're all on there, so you can look at these anytime you want. And I really recommend, if you have somebody saying, hey, should I buy this property on Lake Superior or on Lake Michigan, send them to this site and say, here, you can see what it looked like in 1976 and what it looked like up until last year. And I've done this to a number of people, and I think it really helps them picture what might happen in the future. And so this is a nice example. This is on Madeline Island, on the south side of Madeline Island, and it starts with a 2008 photograph, and you can see it's pretty stable. And 2012, even a little bit more stable. There's still a little bit of bare spot there. And what's in here is clay till, reddish clay Lake Superior till. This is continuing low water level. And then we got 2012 at the top, which you just saw, and then 2017. Now water level is coming up, and it's been up for a couple of years, but it's certainly rising. And look what's happening at the base of the bluff. Now you can see exposed till down here and up here and over in here as well. So all of a sudden, within 2 years, 3 years of higher water level, this bluff is starting to retreat. And 2017, you can see again this bare spot. And then by 2019, water level still high, and you can see the instability has reached really all the way to the top. Now you can see there's some bare soil right along the top part of the bluff, and slabs of vegetation and soil are sliding down. So it didn't take long, a few years, and the bluff becomes unstable and starts to fail. Here you can see it's starting to fail a little bit over here too, and probably this structure here is what's holding the material fairly stable, as it is over here too. And this is another one, that same photograph you just saw, 2019, and now we jump to 2023. So this is just last spring, and you can see what's happened with the lake level has normalized down to about its mean. So it's reduced the amount of wave cutting at the base of the bluff. The landowners put in some riprap here to stabilize it, but the beach is substantially wider, and therefore the bluff is starting to stabilize again. So you see some bare areas, but it will stabilize, the vegetation will take over, and as long as the water level stays down, then this low bluff will vegetate. So one thing this illustrates, compared to the slide you're going to see in the future here ahead of time, is how quickly these low bluffs can respond. I mean, this is, a response of 2 or 3 years on that bluff. Bigger bluffs, this is one again in Lake Superior, and this is 2012 to 2019. 2012, the water level was still low. Most of the bluff is fairly stable. It's sand and gravel for the most part, a little bit of till, but it's almost all sand and gravel. And you can see lake level rises and cuts away the bottom, and now it's starting to slide down. The yellow arrow there is just showing the same place in both slides, and the same with the blue. All right, those are the same building. So a substantial difference in a relatively short time. Another one on Lake Superior. This is also on the south side of Madeline Island, 2008. And here's this boat dock here. And that staircase is this staircase. And you can see wider beach, pretty stable slope. And then a few years of higher lake level, narrower beach, and it's destabilized the whole bluff here. And obviously this kind of thing is nobody's going to build there, but somebody involved, I think that's a county highway, but somebody should say, hey, we might have a problem here with this highway if the erosion continues. Now this is jumping to Lake Michigan. So it's a higher bluff, till at the bottom, some sand and gravel or sand in the middle, and then more till at the top. And this is Mequon Road. So Mequon Road is an east-west road about a mile north of the Milwaukee County line. So it's in Ozaukee County. High bluff, 120 plus feet, and 2017, it's sliding and so on, but no big failures. And this is a case where people are building without I think, much realization what was happening. I've talked to the owner of the place, basically when they started construction. But anyway, they took the house down. There's nothing wrong with the house, but they took it down because they wanted a bigger house. And they did, in fact, push it back a little bit. So here's the same site with the house gone a year later, 2018. And you can see this house is still here and it's fairly close to the edge of the bluff. And there's a couple up here. This one is fairly close to the edge of the bluff as well, but it's got shore protection in front of it. So we jump to there's the 2018 and 2019. they've already got the house up. And it's not much farther from the edge. They brought in a landscape company to come in and regrade the top of the bluff and plant grass. So that's what this is. They had a little place for sitting out there to sit and look at the lake. And then this is the new house going up. And it is a little farther back from the edge, but not very much. And there it is in 2023. You can see it's fairly stable at the top so far, but they've got now riprap at the bottom to try to stop the wave erosion. The problem is, of course, the riprap only goes to here, and so we're getting erosion on the next property south, and you can see a fairly recent failure coming down here. So there's lots of complications on this high bluff environment. Another couple of examples from Lake Michigan. This is Ozaukee County Highway C, about midway up the county from south to north. And you can see this house was getting close in 2018. By 2020, it's time to move out. If they hadn't already, they probably had. And then, sorry, what's happened here now? Yeah, okay, 2021, the house was still there, but obviously nobody living in it. And then by 2022, the house is gone. So the other advantage of having these photographs taken every year is you can really see what's happening on the shoreline in terms of development, in terms of effects of people building too close to the edge or on safe distances away from the edge in houses that have been there for a long time. So I just think it's a good learning tool for people who might be involved in either building on the edge, buying a house on the edge, close to the edge, or whatever. This jumps a little farther south. This is in Kenosha County, north of the city of Kenosha. And here you can see a house that's beginning to be threatened here in 2017. By 2019, it's already hanging over the edge. So this house is that house. The porch has been removed already, but the house is already hanging over the edge, and by this time it had been abandoned. And then in I guess that's 2021, I think it was, the house is gone. So this house is still there. That was there in the last slide. And this house is in there in 2023, but you can see the garage. I didn't point it out before, but there was a garage on this slab in the earlier photograph. The garage is gone now, but the slab is still hanging over the edge. Oops. So I want to finish up by looking at the high bluff in Ozaukee County. This is just north of Concordia College. And we've got a house that you can watch through time here. So this is 1976. These houses have been built not much before that. But notice this white chimney. This white chimney you can spot as we go along. We did a study in 1975, 76, 77, and 78, where basically all the shoreline was walked by either me or somebody from Geological Survey or grad students, mapping what's in the bluff and trying to evaluate what was happening on the bluff. And here you can see, it looks like this might be an old slump block. And we recognize that some of the material here was really the same till that's here at the top. So this is a part of an old slump block that we recognized and thought, therefore, there must have been a big slump there at some time in the past. Then in 2007, here's the same house with that white chimney. Most of that block is gone. We got pretty straight slope all the way down, maybe a little of accumulation at the base of the bluff, but otherwise a pretty straight slope. 2012, here's the house with the white chimney is up here now. And of course, we never have the photos line up exactly because the plane is just flying and trying to take consecutive photos. But there's, again, a little bit of accumulation, probably some sliding, but not any evidence of serious big slumping. Okay, and now in 2021, again, fairly straight slope, no sign of a large amounts of slumping. There may have been some cracking along the top of the bluff here. 2022, I don't know why it keeps jumping, sorry. 2022, boom, there's a big failure, a big slump. This piece used to be up here, it's come down. This used to be the edge of the bluff out here. And what you can see is down here, there's this gray stuff that's pushed up from out in the lake and under the beach. And what this means is that's a deep-seated slump. So this is a profile we made in the 1970s in this part of Ozaukee County. I don't know exactly where it was, but very close to this. Well, we have two tills. This is the gray till that's at the surface down in Kenosha and Racine County. This is the red till, reddish brown till that's at the surface in Ozaukee and northern Milwaukee County. Some lake sediment in between. But the analysis that was done in the 1970s
over here, so
shows likely failure planes.
I got my headphones. I thought I
And this
them,
is
but
the
I must have forgotten to put them in the case.
failure. There's the house with the white chimney. Now we've got this big slump that's taken place. By 23, the waves have removed most of the material coming up from underneath, but that's a deep-seated slump that's typical in this part of Ozaukee County. And it takes, I didn't point it out, but it takes a substantial amount, probably 30 feet or more of the bluff top here.
All right, Dave. Thank you so much. Is there any final thoughts that you wanted to share before we jump into a question that came in through the chat?
Nope, we'll take questions. That'd be great.
Awesome. Okay, well, our first question came from Melissa Scanlon, and she was wondering if the oblique viewer showed the distance the structures are from the bluff or shoreline. Or is that something
really.
that needs to be measured separately?
You mean from where the plane was to the shoreline?
I think the like infrastructure on the coast. Melissa, do you want to come up?
Yeah, I can jump in. No, I was curious about like the setback from the bluff, the top of the bluff or the shoreline to the structure.
Oh, no. There may be someone could figure out how to do that, but because we know approximately the elevation of the plane, but it would take some geometry to try to figure that out. So no, except in a relative sense, no, I don't think so.
Yeah, I know there's another database that has that where you can access that. I just wasn't sure if it was integrated into this. So thank you for answering.
Thanks, Melissa. We also had another question come in from Colin asking if it's possible to use overlapping photos from a given year to create 3D models of the bluff.
No, there's hardly any. There's a little bit of overlap, but not more than probably 10 or 20%.
All right, thanks, Dave. Any other questions for Dave? We have another one about, do we know if FEMA is involved in removing the houses that you've shown in these examples?
Oh, I don't know, but I'm sure that there's probably somebody on here who can tell you.
I don't know personally, but we can ask around maybe and find that answer for you, Melissa.
This is Alan Luloff. Generally, FEMA flood insurance does not cover a bluff structure that's impacted by a bluff failure unless that is an event where there was a storm event associated with it, where the structure kind of immediately collapsed after a particular storm event. But in general, flood insurance does not cover this type of hazard.
Thanks, Al. That's great context. And Andrew put in the chat that FEMA has not been involved in the house removals, at least in Ozaukee County. So thanks for sharing that with us. With that, we're at time. I want to be respectful of everyone's lunch. So a big thank you to Dave for joining us and sharing his lunch with us today. A lot of excellent visuals that we got to explore. So if you do have questions that didn't get answered, feel free to email them to me and we can help get those answered for you. I'll throw my email in the chat. And also, if you think of any topics that you would like to hear about at a future Lunch and Learn, email me with those suggestions as well. With that, thank you all so much for joining and have a lovely rest of your afternoon. Thank you, Dave, for being on.
Okay.
We really